Hello, this is Mrs. Ward, and I'm going to go over the homework from section 4.1, part A. So exercise 1 and 2 asks you to estimate the angle to the nearest 1/2 radian. So that's when we're going back and we're breaking the unit circle into the 0 to 2 pi, which would be 0 to 6.28, because 2 times 2 pi is 6.28. So if you want a visual, that's going back to this picture right here in the book, where I'm trying to figure out which closest radian. So when I look at the first one, let's shrink that. So when I look at this one, I see that my angle of rotation is going in the positive direction. So I know my angle is going to be positive. And then that looks, I'm going to guess this about positive 2 radians. And I'm just sort of guessing that, sort of doing my best educated guess. But I do know that if I'm looking at a unit circle, this would be 1.57, and I don't know why that's so thick. Oh, that's why that's so thick. So this would be 1.57. This would be 3.14. This looks like it's closer to 2 than anything else, so I'm going to guess 2. When I come to the next one, number 2, it's going down, so it's going clockwise, which means it's going to be a negative angle. So going halfway around the unit circle would be negative 3.14, because that would be negative pi, which rounds to negative 3.14. So this is a little bit more. If I were to go straight up and down, that would add another 1.57, so this would be negative 4.7-ish. So I'm going to guess that this is about negative 4, and that's going to be my final answer, is negative 4. It only wants you to the nearest 1/2, so as long as you're close, you're good. And exercises 3 and 4, they want you to determine the quadrant in which each angle lies. So I have 7 pi over 4. When I'm looking at that, I'm going to know that I take 7 and divide it by 4. And when I do that, old-fashioned division from 3rd grade, 1, 4, 3, and so I have 3/4. So when I think about that, this goes all the way around, so that would be, this would be 4 pi over 4. And then this 3 is more than 1/2, so it would put it over here. So 7 pi over 4 is going to be in the 4th quadrant. Remember, the name quadrants, you have to use Roman numerals. So now I have 11 pi over 4. So doing the same thing, if I take 11 and I divide it by 4, I'm going to get 2, 3. So 2 means that when I'm on my unit circle, I'm going to go all that would be 2 pi. That would be all the way around my unit circle. And then I have 3/4 left. So this is 2 and 3/4. So 2 takes me all the way around my unit circle. 3/4 is more than 1/2, so that would put me in the 2nd quadrant. So 11 pi over 4 is in the 2nd quadrant. Now looking at number 4a, I have negative 5 pi over 12. It's less, so I could take 5 and divide it by 12, but it's not more than 1, so I'm not going to do that. I do know that 5/12 is less than 1/2, because, or 1/2, because I was thinking that that's 6/12. So I know it's less than 1/2, so it's going to, I'm going down because it's negative. So I'm going down. I'm not going to make it to the 1/2 mark, so I'm going to be stuck in this quadrant here, which is the 4th quadrant. And then negative 13 pi over 9. I'm going to take 13 and divide it by 9. 9 goes into 13 once. I have 4 left over, so this is 1 and 4/9. It's negative, so if I'm thinking, drawing a picture, this is negative 1 and 4/9. Just to remind you, 4/9 is less than 1/2, because 1/2 of 9 would be 4.5, so it's less than 1/2. So the negative 1 will take me from here to negative 1 pi. Less than 1/2 means I don't quite make it to this mark, so I'm here somewhere. So that means I'm going to be in the 2nd quadrant. And I think drawing pictures helps. Some people think it does, some people don't, so I like drawing pictures. In exercises 7 through 10, they ask you to sketch each angle in standard position. So the first one is negative 7 pi over 4. So to draw an angle in standard position, I have to first start with my initial side. So initial side starts at the origin, goes along the positive x-axis. It goes like that. Negative means that I'm going to drop down. Negative 7/4 is, I'm doing the same thing that I just did in the last section. And I can count or I can actually divide. But this would be negative 4 over 7 because it's negative pi, so negative pi. So if I'm doing this, 7 divided by 4, 4 goes in there once. I have 3 left over, so 3 is larger than 1/2, so I'm going to go past this 1/2 mark and I'm going to end up here. That's going to be my angle, and then to do it correctly, you have your initial side, you have your terminal side, and then you have your angle of rotation showing the direction that your angle went in. So I need this arrow to show me that I went in that clockwise position. Negative 5 pi over 12, again, I'm sorry, negative 5 pi over 2, I read that wrong. So I'm going to take 5, divide it by 2, 2 goes into 5 2 times. I have 1 left over, so this is 2 1/2. So this is negative. So when I go to sketch this, I am going to so negative 2 means here's my initial side. Initial side. Negative 2 means that I go all the way around my unit circle, all the way around. And then I go 1/2 more. So here's 1/2 more. So the terminal side is actually going to be that negative y-axis. And then to show the angle of rotation, I'm going to have my arrow go that way because I started here and went clockwise. So I dropped down, and that would be my angle in standard position. Okay, number 10A is in radians. So I'm going back to that picture that I did before. So I'm at 4 radians. So when I do radians, I like to think of my unit circle. When I think of this, I know that this is 0. Makes sense because I haven't gone anywhere. My initial side and terminal side. This is pi over 2. Well, 3.14 divided by 2 is approximately 1.57. Then this is pi, and as a decimal, because these are decimals, so it makes life easier if I convert it to the same thing. That would be 3.14. Then this is 3 pi over 2. And I can do that calculation on my calculator, or I can add. And when I do that, I get, let me do 1, 11, 5, 6. Oh, that's a 7. Whoopsie. And this is, why can I not add today? Oh, my. Embarrassing. Okay, this is 4.71. And then this would be 2 pi, which would be 6.28. So that's basically how my radians will go. So 4 is greater than 3.14, less than 4.71. So when I go to draw that angle, I know it's going to be in the 3rd quadrant. I'm going to have my initial side always on the positive x-axis. Then my terminal side is, we just said, was going to be in the 4th quadrant. Angle of rotation says that I go counterclockwise, and that would be my positive angle with a radian of 4. B is once negative 3. So negative 3 is going down, so it's going clockwise. It's a little bit less than 3.14. So my initial side is going to be on my positive x-axis. Then my terminal side is going to be going in a negative direction, a little bit short of that 3.14. So showing my angle of rotation. So when we're checking these, we're looking for 3 things. We're looking for the terminal side, we're looking for the angle of rotation, and we're looking for this arrow to show us the proper angle of rotation. So by angle of rotation, I mean whether you're going counterclockwise or clockwise. Okay, number 24, it says determine the quadrant in which each angle lies. So if I go back and draw my unit circle again, this is 0 degrees. This is 180 degrees. This is 90 degrees. And this is 270 degrees. So when I determine what quadrant, 87.9 is larger than 0, less than 90. So that tells me it's going to be in the first quadrant. Sketch the angle in a standard position. So I have 405 degrees. What I notice about 405 degrees is it's more than 360 degrees. So I know I'm going to have at least one full rotation around my unit circle. So I'm going to take 405 and I'm going to subtract 360 degrees. Because when I do that, and I get 45 degrees, when I do that, that subtracting of 360 is taking this angle in standard position. So taking this angle, I don't know why this is taking this angle in standard position. So there it is, standard position. This 360 degrees takes this and wraps it all the way around my unit circle once. And then I have to do an additional 45 degrees, which would be in the first quadrant. And that's my angle of rotation. In order to get full credit, you must show me that you have this complete loop to show that you know that it went all the way around the unit circle once and then up another 45 degrees. Okay, doing 780. I do 780, I subtract 360, I get 420. That's still more than 360, so I'm going to subtract 360 again. And when I do that, I get 60 degrees. So when I go to sketch this angle in standard position, this one, first one, 360 degrees says, here's my initial side. 360 degrees means I go all the way around the unit circle. This one tells me I go all the way around the unit circle again. And then I'm left with 60 degrees. 60 is between 0 and 90, so I know I'm in this first quadrant. So I'm going to have my terminal side in the first quadrant, and here's my angle. Must have both loops to get full credit because I need to show that 780 degrees made 2 trips around that unit circle before it stopped. Okay, number 54, convert the angle measure from radians to degrees. So remember to change radian degrees, you're going to take your 8 pi over 13 and you're going to multiply it by it's either going to be 180 over pi or pi over 180 because on my unit circle, this is 180 degrees, or I can call this pi. So this is my conversion factor because it's 1 pi to 180 degrees. I use units to help me. Since I have pi in the numerator, I'm going to want pi in the denominator. That means the 180 degrees is going to go up here. Using units, which you learned how to do, way back when, the pi's will simplify, and I'm going to be left with degrees as my final unit. Then I multiply. I don't think anything will simplify, so I'm going to get 0. 1440 over 13 degrees. And I can leave it like that, or I can convert it to an actual decimal. So reading the directions, I see it says round your answer to 3 decimal places. So I took 114 and divided by 13 on my calculator, and I got 110.769 degrees, and that would be my final answer. And that appears to be the last of the classwork. If you have any questions, make sure you ask one of us, and I hope you have a great day. Thanks for listening.